All right, let's move on to Chapter 9, Lesson 3, Area of Trapezoids. The two things we're doing in this lesson are finding the area of trapezoids, so we're going to use a new formula, and then we are going to find the height of a trapezoid when we know everything else. So again, that first part here, just plugging in height and bases to find area of a trapezoid. And then here is finding the missing height. So we'll start off with this real world link, and we'll remember how we get the area of a trapezoid based on the area of a rectangle or parallelogram. Window seat. Kiana has a bay window in her room. The window seat is in the shape of a trapezoid. She needs to measure the seat in order to sew a cushion for the seat. The blue trapezoid in the diagram below represents the dimension of the window seat. Use the diagram below to describe the relationship between trapezoids and rectangles. So find the dimensions of each figure. The trapezoid in blue has a base, 1, 2, 3, 4, 5. On the bottom base is 5, so we'll call that base 1. And base 2, 1, 2, 3, is 3. And if you had these the other way around and had 3 and 5, that would be okay too. Now the height is 1, 2, 3 units. So we had 5, 3, and 3. Now this big rectangle though is 5 plus 3 more. So that would be 8 for length, and the height is still 3. So what is the relationship between the measures of the rectangle and the measures of the trapezoid? Now, if you look at this, basically, the sum of the two bases in the trapezoid equals the length of the rectangle, and the heights are the same. So these two bases added together equal the length. So let's talk about that. First, the sum of the trapezoid bases equals the length of the rectangle. And the second thing was the heights are the same. Now make a conjecture. How is the area of a trapezoid related to the area of a rectangle? And we've talked about this. Look at that. This is like the triangles, two triangles making a parallelogram. But what we have here is this trapezoid plus an identical trapezoid, so the same size and same shape, it's just flipped a different way. Two equal trapezoids can make one rectangle. So the area of a trapezoid would be half the area of the rectangle that it creates. So let's write that. Area of a trapezoid is half of the area it can create in a rectangle. Now that's kind of confusing the way I worded it, I feel like. But do you see what I'm saying? This is the rectangle that it can create if you have two trapezoids, if you double the trapezoid. So it's half of that area. And that's where we're going to find a half in our formula. So let's look right here at area of a trapezoid. We have words and then the symbols, which we're calling this formula. So the words say, and this is a trapezoid, the area A of a trapezoid is 1/2, so it's half, the product, this means multiplication, half the product of the height and the sum of the bases. Because if we had this here, and we had the sum of the bases was 8, and we did base times height, that would give us the rectangle, but we need half of it. So the sum of the two bases times the height divided by 2 would give us this trapezoid. This is kind of a little bit more complex than the triangle, isn't it? So here's one way to write the area. 1/2 times the height times the sum of two bases. The other way that you can write this, be sure to write this in because this will come in handy later on when we get down here. Or you can do what we did with the triangle. You can take the height, so area equals height times the sum of two bases. So base 1 and base 2. And we're taking half of it, so it's that divided by 2. Now, it says a trapezoid has two bases, base 1 and base 2. The height of a trapezoid is the distance between the two bases. Again, the height is the perpendicular distance. So it's not this slanted, it's this perpendicular measurement. The two bases are parallel, so they'll always be the same distance apart. So the height along here will always be the same. When finding the area of a trapezoid, it's important to follow the order of operations. In the formula, the bases are to be added before multiplying by half of the height. So this is that whole idea of order of operations. So when finding area, add B1 and B2 first. So the order of operations, remember, you do what's in parentheses first. So I'm going to do this parentheses first, then multiply, then divide. Or parentheses first, 1/2 times height times what that sum was. So keeping the order of operations in mind, let's see this example. Find the area of the trapezoid. So we have base 1, we have base 2, we have height. So to show your work, you plug in those three numbers. Area equals 1/2 times the height is 7, base 1 and base 2, 5 plus 12. So you have to do that first. 1/2 times 7, 5 plus 12 is 17. And if you plug into your calculator, this would be 0.5 times 7 times 17. Or, and that's the 59.5, or it would be 7 times 17 divided by 2 if you use this formula. And some people preferred that when we did the triangle. Divided by 2. I think the reason why I prefer this one is just because you don't have to push an equals sign in between. You can just go all the way through this times this times this, and then it's equals. But it doesn't really take much longer to push an equal sign, does it? Here's example 2. So in this example, they have the height written on the outside of the trapezoid here. So we're going to plug in our numbers. 1/2, here's our formula. The height was 9.8, and the two bases are 7 plus 12. And you have to do this first. 7 plus 12 is 19, and then you can just plug in 0.5 times 9.8 times 19, and that gives you 93.1. We're talking meters, so it's square meters. So let's show our work for this. Here's how you show your work. You plug into the formula. So area equals 1/2 times height times 11 plus 14. So then that's 1/2 times height times, what's 11 plus 14? 25. All right, and then we're going to plug that into our calculator. 1/2 times 8 times 25, and that's exactly 100. What a nice, pretty number. And we're talking centimeters. So over here, 100 square centimeters. Now, just remember, you could have plugged it in. Area equals 8 times 11 plus 14 divided by 2, and you would have gotten the same thing. I'm going to show you on this one. So the 11 plus 14 is 25. So 8 times 25 is 200 divided by 2 is 100. So I would have written it like this. 8 times 25 divided by 2 is 100. So you can write it either way. All right, let's do this one here. Let's plug in our numbers. So we have area equals half times the height times the sum of two bases, 2.5 plus 4.8. So now what's 2.5 plus 4.8? 7.3. So that equals half times 4 times 7.3. So 7.3 times 4 times half is 14.6. And we're talking meters. So 14.6 square meters. All right, let's do this last one here together. So I'm going to draw it down here. Area equals half times the height, 0.3, the sum of two bases, 1 plus 0.5. So that would be half times 0.3 times 1.5. And let's plug it in. Half times 0.3 times 1.5 is 225 thousandths square feet. Cool. All right, so the first part of this lesson is done. We have practiced finding the area of a trapezoid using our formula. Now we're going to find the missing height. So this right here is the formula of how to find a missing height. This is going to be what you need to know for your reflection. Use the related formula, h equals 2 times area divided by base 1 plus base 2 to find the height of a trapezoid. Now, let's talk about why this works. Okay? I need a little bit of space. So let's write this. Why does this work? If you can figure out why it works, then you'll be more apt to figure it out on your own later if you ever forget this. So watch this. Let's start out with the formula for area of a trapezoid, and let's use this one because it's easier to show multiplying both sides by 2. So I'm going to write this out. Area of a trapezoid equals the height times base 1 plus base 2 divided by 2. Now, we're trying to solve this for h. So in the end, we want to get h by itself. And it's going to end up being this on this side. So this side's going to have a whole bunch of stuff on it. We want to get this right here. So how do we do that? To solve for h, we're going to get rid of this 2 first. So let's undo the 2 by multiplying both sides by 2. So that's going to give us 2 times the area equals the height times base 1 plus base 2. Now, we want to get h by itself. So we need to cancel out this. So since it's h times the sum of both bases, we can divide by the sum of both bases. All right, so that cancels that out, but we have to do that on both sides. And there it is. H equals 2 times the area divided by the sum of both bases, which is what they gave us right there. Pretty cool, huh? So that's why it works. Now, let's use the formula that they gave us. In an example 3, it says the trapezoid has an area of 108 square feet. Find the height. So we're going to plug in 108 for the area, 12 and 15 for the bases, and then 2 times 108 is 216, and 12 plus 15 is 27, and then 28 divided by 27 is 8. So the height of the trapezoid is 8. And remember, you can check your answer by using the formula for area. So if we said this was 8, then you would simply, on your calculator, say, okay, half times the height 8 times 12 plus 15, which was 27. I hope I pushed times. And there's 108, which was our area. So now we're going to do these two examples together. We know the area, so we have to use this formula. H equals 2 times the area divided by base 1 plus base 2. So the height equals 2 times 24 is the area, and then base 1 plus base 2. So 2 times 24 is 48, and then 4 plus 12, 12, 13, 14, 15, 16. So what's 48 divided by 16? 3. So our height is 3, and we're talking centimeters. And we can check that by doing half times height times the sum of both bases, which was 16, and that gave us the 24. So 3 centimeters is the height. All right, let's do this one. Again, H equals 2A divided by the sum of both bases. So the height equals 2 times 21 divided by 2 plus 5. So 2 times 21 is 42. And then this 5 plus 2 is 7. And 42 divided by 7, I know that is 6. And we're talking yards. So let's see if that works. So if we have the formula of area of a trapezoid, half times the height, which we thought was 6, times the sum of both bases, which was 7, and that gave us 21. So it works. 6 yards is the height. All right. Last little problem before the guided practice, a little story problem here. The shape of Osceola County, Florida, resembles a trapezoid. Find the approximate area of this county. So see this trapezoid here? These are the two bases. This is the height. So let's plug it in. Half times the height, which is 51, times the sum of both bases, 48 and 16 miles. Half times 51, and then the sum is 64, and when you plug that in your calculator, it's 1,632. So the approximate area is 1,632 square miles. And let's see what this mental math says. To multiply half times 51 times 64, it's easier to use the commutative property. So you could switch around the 51 and 64 and think half of 64, and because that's easier to find than half of 51. It's a nice whole number. So 32 times 51. And then you would get this 1,632. So it is time to partner up and practice more of what we've been learning about in this lesson. So let's circle the ones we're going to do, 1 through 4. And number 1 and 2, we're just using that formula for area, just like we did in examples 1 and 2. So we need to show our work like this. This is how we're going to show our work, okay? So go ahead and show your work for this first trapezoid here. Plug in the numbers to the formula, and then check your answers. Okay, so area is half times height times the sum of both bases. So we're going to do half times the height is h, and then it's 6 plus 11 for the two bases, and that's half times 8, 17. All right, so if you think half of 8 is 4, 4 times 17 is what? 68. And we're talking miles, so it's 68 square miles. All right, now find the area for this trapezoid. Make sure you show your work by showing what numbers you plugged into the formula. So area is going to be half times the height times the sum of the bases, so 7 plus 15.6. So that's going to be half times 8 times, what's 15.6 plus 7? Could probably do that mentally. 22.6. Half of 8 is 4. 4 times 22.6 is 90.4, and we're talking feet here, so square feet. 90.4 square feet. All right, now the next one's a little different. So this is like example 3, where we use this formula here. Height equals 2 times area divided by the sum of both bases. So I'm going to write that over here. Height equals 2a divided by the sum of the two bases. And use this formula to show your work and plug in the numbers here. Go for it. A trapezoid has an area of 15 square feet. So 2 times 15. If the bases are 4 and 6, what's the height of the trapezoid? So this would be 2 times 15 is 30. 4 plus 6 is 10. 30 divided by 10 is 3. So the height must be 3 feet. Now let's see if that makes sense. Half times the height, which is 3, times the sum of both bases, which was 10, is 15, and that was the area. So that works. Cool. All right, now you have one more. This is like example 4 up here when we found the area of this county. But now, in the National Hockey League, goaltenders can play the puck behind the goal line only in a trapezoid-shaped area as shown to the right. So find the area of this trapezoid that the goalie can play the puck in. All right. So plug in the area. This was our formula. Area is half times the base, or half times the height times the sum of both bases. So go ahead, plug it in and find it, and then check your answer. Area is half times the height, that was 11, times the sum of both bases, 18 plus 28. So it's half times 11 times, what's 18 plus 28? 46. Which, remember how they were saying you could think half of 46. So half of 46 would be 23, and then 23 times 11 is 253. And we're talking what, feet? So the area is 253 square feet. Sounds like a lot. So it's now time for the independent practice, and remember, you're doing this on your own. All right, so we're just doing numbers 1 through 5. 1, 2, and 3 are just like examples 1 and 2, so show your work like this. Number 4 is like example 3, so show your work by plugging into this height equals blah, blah, blah formula. And then number 5 is the same thing, so use that height formula. We're not doing number 6. So, got to circle 4 and 5. All right, go for it. All right, so right here, area of a trapezoid. Plugged in the numbers in the formula, half times 12 times the sum of both bases, which was 28, equals 168. That's square yards. For number 2, half times the height is 2. Here are the two bases, which is the sum is 4.5. And when you actually do this out, you get 4.5, and it's square centimeters. All right, plugging in the numbers into the formula. Half times the height is 8. Here are the two bases. The sum is 28. And half times 8 times 28 is 112, and that's meters, so square meters. Plugging in to find the height. 2 times the area divided by the sum of both bases. So 300 divided by 30 is 10. So the height is 10 meters. And number 5, 2 times the area divided by the sum of both bases is 800 divided by 50. which is 16, and that's millimeters. Last thing is the reflection. Get it ready. All right, so we're looking at the reflection. We have to do two things: find the area of a trapezoid and then find the height of a trapezoid. So to find the area of a trapezoid, why do we take half of the height times the sum of the bases? Use complete sentences, relate it to the area of a parallelogram or rectangle, and then sketch it if you need to. And then here, area is A, B1 and B2 are the bases, and then H is height. So what are the two ways to write the formula for area of a trapezoid? And then label base 1, base 2, and height on this trapezoid. Find the area of these trapezoids. Show your work by showing the formula, so plug in the formula. On the back, if you know the area of a trapezoid and length of base 1 and base 2, you find the height by following this formula. So what is that formula that we use? And then find the height. So plug the numbers into that formula. Show your calculations, and you can use a calculator for these two. That's it.